Okay, now sums from chapter light. Here we are supposed to fill the gaps. The focal length is given in meters, and the power of the lens is asked, that is in diopters. Okay, so the first part, the focal length that is given in meters is 0.2 meters, and the power of the lens that is in diopters is asked. Okay, the formula is very simple. Power is equal to 1 upon focal length in meters. This will be equal to 1 upon 0.2. You can shift the decimal to the right. This will become 10 divided by 2. So power is equal to 5 diopters. Second part. Okay, here the power is given, that is 2 diopters. We are supposed to find the focal length. Okay, so here focal length is equal to 1 upon power, that is the reciprocal formula, that is 1 upon 2. If you divide this is going to become 0.5 meters. The third part. Okay, here the focal length is 0.1 meters. Power we are supposed to find, which is going to be 1 upon focal length in meters. This is going to become 1 upon 0.1. Again here also you can shift the decimal. Okay, so this is going to become 10 divided by 1, which is going to become 10 diopters. Now next part. Here H1, H2 and M. Okay, here M stands for magnification, H1 is the height of the object, and H2 is the height of the image. So here we are going to use the magnification formula. Which is equal to H2 upon H1. That is nothing but height of image divided by height of object. Okay. Now in the first case, magnification is -2. That is equal to H2 is -30 divided by H1 is what we are supposed to find. You can bring this H1 up. You can bring this -2 down. So therefore I am going to get here H1 is equal to -30 divided by -2. Minus sign will get cut. 2 will go with 15. So here the height of the object, that is H1, is 15. Second part, here we are supposed to find the magnification. So magnification direct formula H2 upon H1, that is equal to -20 divided by 5. That's going to give me the answer -4. Remember, magnification will have no units. The third part, here H2 is asked. Okay, so I'm going to write the same formula. Magnification is equal to H2 upon H1. Just do the substitution. Magnification is -0.5. That is equal to H2 is asked. Okay, H1 is 10. Okay, I can bring this 10 here in the numerator. -0.5, I can shift the decimal. I can write that as 5 upon 10 when I shift the decimal of 0.5, and this 10 is going to come up in the numerator, so that will be multiplied by 10. This is going to give me H2. You can simply cut this 10, 10. So H2 is equal to minus. Okay, now sum number 1. An object of size 7 centimeters is placed at 25 centimeters in front of concave mirror of focal length 15 centimeters. At what distance from the mirror should a screen be placed? Now answer is there in the question itself. They have said it is at what distance from the mirror should a screen be placed. It means the image is real and inverted. Okay, so that we can get a sharp and clear image. find the nature and size of the image. They have given that in the question itself. Okay, at what distance the screen should be placed, it means the image is real and inverted. Alright, we'll solve the sum to get the image distance and the height of the image. First of all, what is given to us here, height of the object, that is h2, is 7 centimeters. Height of object is always positive. Is placed at a distance 25 centimeters in front of a concave mirror. Okay, object distance is u, it is always negative, minus 25 centimeters. Now the focal length of the concave mirror is given. Focal length is 15 centimeters. It's a concave mirror, so it is going to be minus. Now here, first of all, we are going to use the mirror formula, which is 1 upon f is equal to 1 upon v plus 1 upon u. Okay, I'll substitute 1 upon f means 1 upon minus 15, that is equal to 1 upon v, that's what we are supposed to find, v, plus 1 upon u will become 1 upon minus 25. Okay, I'm going to take this minus 1 upon 25 on the left side, so this is going to become 1 upon 25 minus 1 upon 15 is equal to 1 upon v. So this becomes 25 and 15, the LCM is 75, 25 3s are 75, 15 5s are 75, this is equal to 1 upon v. 3 minus 5 is minus 2 upon 75, that is equal to 1 upon v. So reciprocate this, v is equal to minus 75 upon 2. You can divide this, you can write this answer as v is equal to minus 37.5 centimeters. Okay, this is the image distance. The image is at the distance 37.5 centimeters away from the mirror. Okay, so that is the position where the screen will be placed. Second thing is we are supposed to find the height of the image. So I can use the formula for magnification of mirror. The formula for magnification for mirror, it is going to be minus v upon u, that is equal to h2 upon h1. Okay, we have found out over here v, u is given, h1 that is height of object is also given. What we are supposed to find over here is h2. So I'll just substitute these values. Now 37.5, I can write this as minus 75 by 2. Object distance is 25 centimeters, that is minus 25. That is equal to h2, that's what we are supposed to find. h1 height of object given is 7 centimeters. Of course, this is with the negative sign. This minus minus will become plus. Okay, minus sign will remain. Okay, I can write this as 75 by 2, that 25 remains in the denominator. 25 3s are 75. I can bring this 7 up. So 3 multiplied by 7, that is going to become 21 divided by 2, that is h2. So h2 is equal to minus 10.5 centimeters. Okay, the negative sign indicates that it is an inverted image. Okay, so obviously the nature of the image is going to be real and inverted. The height of the image is going to be 10.5 centimeters. Now next sum. An object of height 5 centimeters is held 20 centimeter away from converging lens of focal length 10 centimeters. Find the position, nature and the size of the image formed. Now first of all, an object of height h1 is equal to 5 centimeters is held 20 centimeter away from converging lens. Converging lens is convex lens. So its focal length is going to be positive because it's converging lens, that is convex lens. So the focal length is plus 10 centimeters. We are supposed to find the position, nature and size of the image. Okay, here the object distance u that is given to you, that is 20 centimeters, which is always negative. We are supposed to find v, we are supposed to find h2, that is the height of the image. Now here we are going to use the lens formula, that's 1 upon f is equal to 1 upon v minus 1 upon u. So that will give me 1 upon 10 is equal to 1 upon v minus 1 upon minus 20. Now on the right hand side you can see here this minus minus will become plus, but again when you bring it on the left hand side it is going to become minus 1 upon 20. 1 upon 10 is already there. This is equal to 1 upon v. Okay, 10 and 20 LCM is 20. 10 2s are 20, 20 1s are 20. This is equal to 1 upon v. 2 minus 1 is 1. So that is 1 divided by 20, that is equal to 1 upon v. So I reciprocal this. This is equal to v is equal to 20 centimeters. Okay. So this is your image distance. You can see here this is positive. It's going to be real and inverted image. Next part is magnification formula. That is magnification is equal to h2 upon h1. That is equal to v upon u. Now h2 is height of image that we are supposed to find. h1 is 5 centimeters. V is image distance, which is 20 centimeters. U is object distance, which is minus 20 centimeters. This 20 will get cut, will become minus 1. So h2 is equal to minus 5 centimeters. You can see in numerical value the height of object and height of image both are same. Okay, the only thing is that the object will always be upright or erect, and here in this case the image is inverted. So here the nature of the image is real and inverted, and the size is 5 centimeters, that is the height of the image is 5 centimeters. This will happen when the object is placed at double the distance of focal length. That is, you can see here the focal length is 10 centimeters and the object distance is 20 centimeters. So the image distance is also same, the object distance is also same, and the height of that is same as height of the object. This is going to happen when the object is kept at double the distance of focal length, that is, it is kept at the center of curvature. Now next sum. An object is placed at a distance 10 centimeter from a convex lens of focal length 12 centimeter. Find the position and the nature of the image. Now here the object distance is given u, that is 10 centimeters. Remember, always object distance is negative. Then focal length is given is 12 centimeters. It is a convex lens, so focal length is going to be positive. Okay, we are supposed to find the position and the nature of the image. Here we are going to use the lens formula, that is 1 upon f is equal to 1 upon v minus 1 upon u. Okay, so that is 1 upon 12, that is equal to 1 upon v minus 1 upon minus 10. So this minus minus 10 will become plus. Again it goes on the left hand side, is going to become minus 1 upon 10. 1 upon 12 is already there. This is equal to 1 upon V. 12 and 10 LCM is 60. 12 5s are 60. 10 6s are 60. So 5 minus 6 is going to give me minus 1 upon 60 is there. This is equal to 1 upon V. So you just cross multiply this. I'm going to get V is equal to minus 60 centimeters. The negative sign indicates that the image is on the left hand side. It means the image is virtual and erect. Okay, here the position of the object is between the focus and the optical center. Such a device is used as a simple microscope. Here we are getting a virtual and erect and a magnified image.